Hello everyone, and thanks for attending today's webcast on SCM transformation challenges and how to overcome them. I would like to introduce you to our speaker. We're extremely pleased to have with us today Compuware specialist Lars-Erik Berglund, who will cover this interesting topic. And with that, I would like to welcome and hand things over to Lars-Erik. Lars-Erik?
Hello and welcome everyone. My name is Lars-Erik Berglund. I'm a technical account manager at Compuware. And I'm here today to talk about today's topic, SCM transformation challenges and how to overcome them. I'm the one to blame for many SCM implementations around the world from 85 up to 2006, when I used to work as a technical consultant, then for Legent, and then CA, and later on at Volvo IT. Now with the Compuware, I'm back into the SCM world again with ISPW. Times are changing and new work practices are needed in response to velocity, quality and efficiency. And SCM implementations need to be revisited, replaced, in order to support new work practices. So what's challenging IT today? We've heard that a number of times from various sources, but it's all about velocity, efficiency and quality. Those are the business pressures that IT factories need to live up to today. And trying to meet those business requirements, we need to look through the way we work, the way people are, the roles they have, the processes they are part of, where they deliver value to the business, and the funding or the underlying technology being in use, whether it allows or enables or disables a move towards higher velocity, higher efficiency and better quality. If we decide to go down this route, then we need to address and introduce new work practices, more automation of course, and also re-engineering or replacing outdated technology. Agile, automated and modern. Yes, I have some personal experience of this with the former employer I had. They introduced ITIL processes and a process chart. So they defined and they established the processes, but some of the processes were not properly implemented. So that was a bit of a setback. There's a huge distinction between an established process and an implemented process. Next thing was they also introduced agile work practices with Kanban boards and planning meetings, stand-up meetings, retrospectives, demos, 14-day sprints, and they also introduced Jira as a tool to manage the work within the various teams, even the mainframe teams. The problem was, of course, that no one looked through, the need to re-engineer or change the mainframe lifecycle models that we have had, implemented in Endeavour and in MMR. And after the Agile introduction, they went on to actually do a lean wave So we learned how to analyze workflows, delivery chains, and identify constraints. This was all very good and well and very educational, but we were highly siloed still. So any idea on improving the delivery chain would come to a halt as soon as someone else in the organization needed to change. But this is what it's all about, doing Agile DevOps, maybe shifting from project focus to product focus, where you have a team of people doing both development, maintenance and IT operations as part of one team or surrounding a product. So yeah, I read a book a few years back. It was called the Phoenix Project. I'm sure some of you have already read it. This talks about IT as an IT factory like operation, where you have incoming goods into the factory like business projects, internal IT projects, planned changes and unplanned changes. And on the other side of the factory you have ready-made deliverables to be delivered to your end users, and they would rank you on speed, efficiency and quality, of course. The blue dots in the factory represent workstations, and the book talks about 3 ways through the factory and the various workstations. First of all, you have the left to right, the production line, where you gather requirements, you do analysis, and then you might do design, develop, code, test, and then ready. The next way, the second way, is right to left. Going back in retrospect, trying to figure out why the deliverable was delayed and what caused it, and then take measures to avoid any future delays based on the same reason. And the third way through the factory talks about practicing and repeating your individual workstation, and also innovate. So if you can do things smarter, do things quicker, do things in a different way that improves for not only you maybe, but many others, then that's fine. So if you go to your own IT factory at home, where do you see the queues and delays in the production line? Realities today is different than 30 years ago. Today a transaction is looking pretty much similar to this picture, which happens to be a Dynatrace screenshot. Far away to the left you see a web request coming in, maybe from a mobile, maybe from an iPad or a laptop or an end device of some sort. It hits the web server, and the web server will talk to an application server. The application server would probably be something like a WebSphere JVM or a .NET server. The JVM will issue some JDBC or database calls to various nodes in the network to get data. It might also call an enterprise service bus. For those of you that have implemented SOA services, then you'd go to SOA server and request the get customer service. And the get customer service would need then to access the backend systems, the COBOL programs,
the data store in DB2 to get the requested customer information and feed it back through the service bus back to the JVM, back to the web server, and then post it back to the end node. And to provide a real good customer experience, you need to keep track of all these pieces, parts in the transaction that make up the actual transaction. And we call the distributed side systems of engagement, where you typically work already in a fast, agile way with modern tools, and you deliver in 14-day sprints or maybe monthly code drops. Whereas the back-end systems, we call them systems of record. That's where the legacy systems and the applications driving your business reside, and also the data, large portions of the data that is used. And over the years, we've built a monster there that, disables us from going very quickly in delivering in 14-day sprints. We might deliver twice a year, or maybe 4 times a year at best. And maybe emergency fixes are the only things that are allowed to travel quicker in the back-end systems up to production.
So the challenges with mainframe SCMs is in fact that in 30 years ago I traveled around to a lot of places, and a lot of my colleagues too, to implement best practices of the 1990s. And remember, this was the pre-Java, pre-commercial use of C, pre-web servers, pre-work practices of modern cut. So I think the best thing we had in those days was RUP, R-U-P, where you did requirements, and then you did design, and then you do manufacturing, and then you do testing, and then you did deployment. And you had a life cycle where you had the various runtime environments up your trunk that enabled you to test. But it was pretty much a waterfall-based solution we implemented in those days. I'll get back to that. So the question now, and the challenge now for mainframe SCM, is whether to re-engineer what you have and build more additional code on top of the standard product you already had some 30 years back, or whether to stabilize and start new. I'd also point out that it's not that easy to re-engineer an SCM solution that was from the very beginning designed to work in a waterfall. And the people I met back then in the late 80s, early 90s, and mid 90s maybe, some of them are still maintaining the stuff we implemented back then, and they're not getting any younger. And how do you address the fact that your SCM admin is retiring or actually moving out of work? How do you onboard some new SCM admin to take over from the person retiring? There's also a fact that continuous integration was hard to automate. If you had a lot of parallel development going on in the lowest level, there was always this question about how to retrofit code and whether to start with the retrofitted code from the bottom of the chain or the trunk and move it back up again, or whether to try and solve the continuous integration issues some other way. And there was also a challenge with the fact that the tools of the 1980s, 1990s, they were user interface based, they weren't graphical. And the ZOS platform in a 3270 environment doesn't lend itself to be an engine for integration cross platforms. It's pretty tough, pretty hard. And also these days, as people has grown into Java and C and other technologies, to other languages and other tools, if they were supposed to dip into the ZOS platform, they would feel like it's text TV. So it won't help onboarding them. You need to move to a GUI. That's the challenge. And then the way we built SCM solutions in the early 90s was actually to populate the runtime libraries and do LLA refresh or new copies in the KICS regions automatically as part of the promotion of a program from one test environment to the next. And the question these days is whether or not this is a good practice. Aren't we going to make a distinction between, distribution libraries and deploy target libraries instead, and do controlled deploys? That's one challenge. It's got to be addressed. So this is a bit of a historical journey, the evolution of SCMs from the 70s and onwards. And you started off with simple functionality. You moved on to something that became a commodity with all developers, and nowadays you need a Ferrari Testarossa to support what you need. In the early 70s, the problem to solve was actually to be able to signal between two developers that I'm currently working on the code, and then do some version control so you could actually see the net differences between your old and your new version of the source code. And also you could reverse back to a prior version. These are the SCCSs on the Unix side and the librarians and the Panvalays of the world. But in the 1980s we saw the birth of Endeavour, LMF, SCLM, Changeman, Proteus, and various other mainframe SCMs. So they moved from being source code managers to software configuration management tools. So you took a larger grip on automation and auditing and supporting more types of code, not just program code. Things like footprinting or fingerprinting started to occur, and you also wanted to package a number of programs together, and the package needed to be approved. You needed some integration to the native security system or the MVS security system, the RACFs, the top secrets, and the ACF2s of the world. And maybe you also wanted some integration between change control and change management. So when this was offered onto the market, and this was really some fun days to work with SCMs, customers of Librarian and Panvalet, they migrated across to modern tools. And the thing is, how do we move from a Beetle to a Ferrari test? Disciplines today require support for continuous integration, delivery, continuous deployment, automatic code scanning, automatic checking of quality gates, automation of tests, unit tests, automated integration of tools that enable you to actually improve quality on your code while the patient is on the table or while you're in edit mode, and various ITSM integration. This picture shows an implementation from the 80s, 90s, typical implementation, and I've been doing several dozens of these implementations, both in Pacific Rim and in the Nordics. And I've been supporting customers with this kind of setup as well. You see the trunk with dev, test, S-test, A-test and prod. And you see an emergency fix life cycle there. And as you generate and promote code up the life cycle, then you distribute stuff to the runtime libraries. So you start down in dev and edit code, and then and there's supposed to be an animation going here. There you go. So as you move your module up from test to systems test, the module will actually be copied across to the next step runtime library. Upon a successful copy, he goes back to the sending stage, test stage, and deletes behind. And that went on like this. So all the IMSs and all the KIXs would have a concatenated list of libraries reflecting the life cycle in the RPL chain, DFH RPL chain, or in the IMS regions. And the most current version of the code would be in production if nothing was going on maintenance-wise with the modules. So even though you were running in the test KIX system, you would actually pick up modules from the prod KIX library. Over time, the solution grew into several more parallel development environments, since we all wanted to work with greater speed. Things needed to take place in parallel, and this of course caused some concerns as to how to solve the continuous integration question. You can see the continuous integration points here. Excuse me. Where you actually have to merge code and then recompile code and then retrofit code. This is what we need today, and you can see this is the Ferrari Testarossa, where you have the development environments all the way down here. You can recognize them, and you have the life cycle trunk right there. This one, I don't know, maybe you can get rid of it, hopefully you can. And what this requires is for you to be able to regress code or maybe merge code. When you merge code, you need to automatically, of course, compile it again, test it again, scan it for security exposures, check that the test case scenarios went through at the quality gate level that you expected, so you don't introduce any new bugs prior to promotion. And then, of course, in order for you to reach the runtime libraries, you would ideally have a deploy tool that can orchestrate the deployment not only of ZOS components but also of Java components or web components. So you can package all the pieces, parts together that make up a transaction or an application. When things fail in production or in the various runtime environments, you'd like to monitor the environments, and you want to check for tuning. If you find any tuning worthwhile doing, or if you run into an append, you want to extract the data that you've discovered or the append itself, feed it into a Jira ticket that ends up in a backlog with a development group responsible for the product that failed, so they can immediately start working on the unplanned change in the current sprint. So, looking at people, mainframe developers, who are they today? Well, they're typically 50 plus. They are loyal, considered experts, using the tools and the processes in order to do their job. They're seasoned ISPF environment users, so no one needs to tell them how to copy or create or delete or promote data. But they're new to the concept of thinking enterprise. And I'll clarify that. As you saw in the previous picture, you had deployments of packages of software to hit various components in the infrastructure, the web server, the Java JVMs, and the ZOS runtime libraries. And you can actually build Jenkins pipelines to manage automatic feeds into the deploy engine. And the feeds themselves will actually be deployed by a deploy tool to the various servers around that need to be around in order for a transaction to work or an application to work. When we look at Jenkins pipelines, there are simply so many manual steps that mainframe developers do today that can be automated. One thing that I think we should take real good care of is the knowledge from mainframe developers as to why things are slow. A developer wants to see his program in production, and if it takes half a year to get it there, they know why. If it only takes 2 weeks, they still know why it's slow, why it's not instant. And they are the center of knowledge when it comes to finding constraints. On general, I would still say that mainframe operations in productions today work pretty much thanks to heroic efforts from IT applications personnel standing up in the middle of the night, saving the kingdom and hopefully winning the princess. And it's what millennials would call old school. So let's look at the millennials. Stackoverflow did a survey of 64,000 developers on the distributed side last year, and they ended up with a 50-page report, and I've borrowed three of the screenshots there. What you see on this first picture is the various ecosystems of tools and technologies that millennials use when they develop software. The size of the various blue, orange, dark blue spots there are the percentage of developers that think they have good command of the technology, the infrastructure, the database, the IDEs, and the platforms. So down to the left you see the .NET or Visual Studio ecosystem. A little bit to the right you see a rather big blue dot with the Java ecosystem, which ties into Android and iOS. And on the left hand side, on top of the Visual Studio stuff, you see the Node.js, AngularJS ecosystem. So this is what they work with. Okay, so I guess they're using pretty modern tools, because none of these ecosystems existed 30 years ago. And what do they use for work practices? Well, 77% or 76.9% are using Agile work practices, or maybe Scrum, or maybe both. And what SCMs do they use? Well, all of them use Git, more or less. Very few use Subversion or Team Foundation Server or some other tool. This is an interesting observation, because this is tomorrow's mainframe developers. What do you think? Here's a somewhat fictitious organization chart, but it resembles organizations I've been working with in my prior career. We have the CIO in the top, and you've got some budget control, you have a steering committee, and you have a dev leg and an ops leg with some group officers on both sides. And then you have the orange and the dark blue teams that are the people actually doing the hands-on work. And I'm going to ask a number of questions here. So the first one is, who's responsible for developing code? Well, that's the developers, of course. How agile is your budget? Does it leave room for innovation? Well, IT controllers normally don't like to work in 14-day sprints. They have an annual budget. But so any move towards going agile with your development and ops teams would have to include the budget control department. Who knows best how to improve customer experience? Well, I'd say the developers knows, because they have developed and tested the code. Some things they might not be 100% happy with. Some other things are maybe things worthwhile launching. On the ops side, the developers might find some assistance in the orange teams on how to monitor performance, response times, and actually get ideas on how to improve
transaction times. So it's partly the Orange team and partly the developers that knows how to improve customer experience. Who knows best how to improve speed in delivery? Well, I'm sure both the Orange team and the developers and also the various group managers on the ops and dev side knows why things take time. And the question is, do they all have the same ambition on going quicker? Who knows best how to improve quality? Well, we've spoken a little bit about that, so I'll skip that question. Who knows best how the application works? Well, I'd be surprised if the developers aren't the ones best equipped to draw an application workflow chart. They've been testing the application in the lower testing lifecycle stages, and they've run into databases that have been corrupt and servers that have been, down, and various things you do on servers that you need to instrument on servers to make applications work the way you want them to. So I'd say the developers there. So this should really read infrastructure, and of course it's the developers. Maybe in combination with the network and platform admins and the IT production admins that knows more about the network and the firewalls and the firewall rule sets that need to be in place for things to work. Are we involving the right people in the IT factory decisions? Well, that's my question. If you want to go Agile, if you want to go DevOps, and if you want to make sure that you can work without constraints in the IT factory, you need to ask the people that are actually doing the work. We're talking about people up to now, and if we look at the processes that are on top of the technology that is in use in ZOS, we talk about the incident and problem processes, the change and release processes, the steering and controlling processes for IT development, and then also the compliance and also the development production model. How is systems and applications manufactured by the IT factory today? There's a whole lot of things that can be picked up from the web, from the net. I listened to Just Humble when he presented in Agile conference in Orlando back in 2017, and what specifically caught my ear was that he was saying that he was doing a contract with one company, and going through some DevOps work there, he understood that out of 318 IT controls on the change on the ops side, 259 of them could be automated. So we need to look through all these things and make sure they are, servicing clients and not servicing an internal organization. Just a bit on that topic too. This is when technology outruns policies and guidelines. You can read it. I'll give you 5 seconds. So I'm down to my SCM recommendations. Take a good look at where you want to be in X years' time. What do you want to do? What's stopping you from acting more
with more velocity, quality and efficiency? Do you have technology around you that enables you to make that move? Please plan for change and also figure out how to measure progress. And when you go about doing your work, form cross-platform partnerships with the millennials and the various ecosystems we saw from the Stackoverflow survey. You probably have your Jenkins expert sitting there somewhere. You probably have your Sonar expert sitting there somewhere. You might have a Splunk expert sitting there somewhere. You might have Java developers sitting somewhere else. And form cross-platform partnerships and take the opportunity to see how they do when they develop code, what the IDEs look like and what functions, features they have. That gives you good ideas on how to move forward with your mainframe stuff. And then utilize new technologies for application understanding. Yes, onboarding new millennials onto the ZOS platform is not easy. And if you can give them a graphical user interface with tools that actually analyze your COBOL code from the 1980s, and I believe there are some really big fat programs sitting out there, like several 100,000 lines of COBOL code, you would typically need to do refactoring, or you would typically at least need some help in analyzing that code in a graphical way. So make sure you provide good tools for the new millennials, otherwise they will just shift jobs. And then one important thing is to focus on how to do testing without runtime environments. And with the help of some Compuware technologies, you will see that you can implement real automated unit testing without the need to use runtime environments, fully integrated in your IDE. Splendid. Ask Compuware for a demo. And also, of course, the start of re-engineering your mainframe tool set is to actually dig deep into your source code management solution and figure out, you know, if your SCM admin is going to retire, how much additional work is built on top of the tool, who else is in line of taking over the responsibilities, should this guy be run over by a bus, and if the work is too cumbersome for you, then maybe you should contemplate stabilizing what you have and start fresh. So those are my recommendations. And I have a few memory points on the right hand side there. I told you on the first slide that I'm partly back into the SCM business again since I started with Compuware. Compuware acquired ISPW a few years back, and it is arguably the best practices tool of 2018 for ZOS mainframers. It has a graphical user interface under Topaz Workbench with the ISPW plugin, which presents information from the SCM in a graphical way. It can be integrating using web REST API calls. It could be accessed by Jenkins. It's got all sorts of good features that we added on top of the ISPW standard product since we actually took over that product. It will simplify onboarding of new millennials to take over from the retiring workforce of the COBOL applications. And the Topaz Workbench with the ISPW plugin also contains various accelerators like Program Analysis, Runtime Visualizer, Topaz for Total Test, an SQL editor, and Enterprise Data for masking and accessing data on heterogeneous platforms. And it enables automation via Jenkins pipelines to do all these things. It has good support for merge, commit, build, test using stubs, code coverage and scanning. It has to do with continuous integration and continuous quality. It integrates with ease with ITSM tools like Sonar or Quivan I ran into. Fortify is another example. And continuous delivery, continuous deploy. If you rethink this thing with distributing straight to runtime libraries and instead distribute them to distribution libraries, then you can employ some pretty smart tools on the market to actually do orchestrated deploys to various heterogeneous platforms at the same time, and reversing them out again if they failed. So ISPW, I think, is the best practices of 2018 when it comes to Mainframe SCM. It's been a rather long presentation. It's 47 minutes, and I'm just finalizing this with some few takeaway points and also some Q&A later on. But my first takeaway point is, sitting back doing nothing is, or trying to run faster is not viable. You need to move on in order to meet business demands. And even though it's cumbersome to replace your SCM, don't be afraid to do it. We do it all the time. Changeman to ISPW, Endeavor to ISPW, various other solutions to ISPW. It's quicker than you think, and it can be done for small companies, big companies. We have our own team of people that can help you out with this. And my observation is that every single ZOS site says, no, we can't do that, we're too unique, we have too many special solutions. But that makes you all equal. You're all equal in the fact that you have things that are unique. But you're not the only one in the world running Packbase or MMR or some other obscure tool that you've integrated with. And please remember also that just changing the SCM will not do the full trick. It is the start of your journey. You need to review the entire DevOps toolchain for full effect. And you should try and focus on the constraints if you want to accelerate velocity, if you have a higher pace. So that's my wrap up, my takeaways, and I'm now ready to take some questions.
Thank you, Lars-Erik. We did receive quite some questions, but let me first remind to everyone attending that you can still submit questions. Now, looking at the questions that we have received, the first question that I would like to ask you is, we have Endeavor since 28 years and we have built a really sophisticated engine using that SCM. Are you telling us that we need to change?
The answer is yes, or maybe can you re-engineer your Endeavor to act as a sophisticated engine supporting CI/CD, Agile DevOps, and support many of the IT controls on the ops side that are manual processes today. Can you go to GUI and integrate with ease to Jenkins pipelines and CM ITSM tools? If you've had Endeavour for 28 years, that means you implemented it in 1990. That must have been on release 2.5 or maybe release 3.0. And the best practices back then was a root-based production model supported by a waterfall-based SCM. Not much Java back then, nor commercial use of C. Agile practices wasn't invented, nor was DevOps or multi-tiered applications. There was not much talk about making the mainframe an equal citizen. It was the citizen. Endeavour in those days only came with the classic user interface in ISPW. And some banks and insurance companies completely rewrote the front end to Endeavour using Rex and ISPF panels. Then, to make sure everything was kept in sync, they integrated the solution with other tools like DMR, MMR, IDMS, Adabas Natural, Packbase, IDL Datacom, IDMS, Telon, Mantis, UFO, cross-system product and data dictionaries. So there's a lot of legacy there. And now when Broadcom is about to acquire CA Technologies, the old BST product from Boston that sprang out of Aetna Life, will most likely become subject to optimizing profit with a minimum of support and other worldwide resources. Mira, next question please.
Another interesting question that we have received is, I'm more worried about the cultural changes on the mainframe side of our IT factory, and I wonder what recommendations you have to convince my colleagues, co-workers and management that changes are necessary.
That one I'm going to answer in a very Swedish way, and it's a lengthy answer. Talks about strategy and stuff like that. So no one likes being told to work differently. It has a large resemblance to the not invented here syndrome. So here we go. When defining your strategy, you must start with the why question. Changes are necessary to meet business requirements. They are velocity, efficiency and quality, or else something expressed with a bit sloppier tone like 25% cost cut on IT. What will happen if I do nothing? Nothing, of course, and your business objectives will never be met. So what you do is you define your desired state, your current state, and you analyze the gap between them. And the result may be obvious to you, but don't assume for your own good that no one else understands it all. You also analyze what might oppose or challenge your strategy recommendations, and also try to define how to mitigate those opposing points of view or challenges to your strategy. Next, the what question needs answering. So if I want to go and work using Agile DevOps practices, I need to re-engineer or replace my SCM tool and other tools in the mainframe that cements the waterfall-based work practice. If you change people's roles and the IT processes without addressing technology, your strategy will fail. If I want more automation, I need to focus on providing state-of-the-art testing tools, also on the mainframe. Ideally, these tools can run automatic tests without runtime environments, bringing costs down and quality up.
If you're staying on the mainframe of the foreseeable future, make the mainframe an equal citizen to other more efficient platforms. Okay, so now you have a strategy and you believe it will meet business requirements. So how do you sell it internally? Well, throughout your strategy work, you've interviewed people, process owners, various teams in gaining ideas, input to the strategy. So how do you make others believe it? When you present it to all, make sure everyone understands the reasons for change and also understands what parts are to be improved or automated. Make sure everyone understands what's in it for me. That drives up motivation and attitude and willingness to participate. You will end up, unfortunately, with 3 categories of people: the enthusiasts, the neutrals, and the naysayers. And typically you onboard the enthusiasts to be part of implementing the strategy. You work on the neutrals to become enthusiasts, and you neutralize the naysayers. Be sure to measure progress as you advance with the strategy and make the results public. Let other people see that yes, indeed, we deliver more without constraints, with better quality. Mira, any more questions?
I think we still have time to answer one more question. And what is the most important thing to take action on if going DevOps?
Okay. This question should really go to people like Just Humble or Rick Slade or someone who's recognized as a DevOps evangelist. When it comes to mainframe adoption of DevOps, I'd suggest to take a stock of all products that cement the waterfall. They are your prime candidates to replace. From own experiences, I know SCMs are one of them. Engineer it to fit your DevOps effort. Lift across system by system to ISPW. Do not port all old functionality to work the old way. That means it's just moving your waterfall to another tool. The earth moved. It's time for your SCM to move with it. As said before, when changing roles and processes, don't forget to enable your move by replacing outdated technology. Do we still have time to answer more questions, Mira?
Looking at the clock, I see that we are running out of time, and unfortunately we won't be able to answer more questions. With that, I would like to thank you very much, Lars-Erik, for covering this interesting topic, and thank you everyone for attending today's webcast. For those questions that we were not able to answer in today's webcast, we will make sure to follow up after the webinar. Please make sure to complete our survey before you exit the system, and in the next week you will be receiving the recording from today's webinar. In the meantime, if you have any questions, do not hesitate to reach out to us. So with that, I would like to conclude our presentation and would like to wish everyone have a great day.